Hi guys, today we're going to be looking at a question on organic reactions. Question 4.1. Three reactions of organic compounds from the same homologous series are shown below, these being the reactions. Question 4.1.1. Define a homologous series. Homologous series is a series of organic compounds that can be described by the same general formula and have the same functional group. Question 4.1.2. Name the type of reaction represented by I. So in I, we can see that we have an alkane plus bromine, and it gives us an alkane, haloalkane plus P, which is unknown. Therefore, the addition of an alkane to a halogen to an alkane is known as halogenation, or alternatively, you could have just said substitution. Question 4.1.3. Write down the formula of the inorganic compound P. So, as we can see, we have butane and bromine. Butane having 4 carbon atoms and 10 hydrogen atoms, and then we add 2 bromine atoms. But only 1 bromine atom will form part of the new haloalkane. So P would have 1 hydrogen atom and a bromine atom. Question 4.1.4. Give the structural formula of a positional isomer of 2-bromobutane. So, bromobutane has 4 carbon atoms, and since we have 2-bromobutane and we want a positional isomer, and we have 4 carbon atoms, we will then put the bromine atom on either the first or the last carbon atom, as that would still mean we have 1-bromobutane, which is a positional isomer of 2-bromobutane, and this is what it would look like. Question 5.1.5. Using molecular formulae, write down the balanced equation for reaction 2. In reaction 2, we see we have pentane, which is an alkane, plus oxygen, and through heat, we form products that we need to determine. So we can start by using the formula for pentane, which is C5H12, and we add excess oxygen, which is O2, and this process is known as combustion. So we should form CO2 plus H2O and then excess energy. Now to balance this equation, we need to make sure that we have the same amount of each atom on each side. So as we can see in the start, we have 5 carbon atoms. So in order for that to be balanced, we need to put a 5 by the CO2. This is 12. But then, now that we have put a 5 here, the O2s are no longer balanced, as we also have H2O. So in order to balance the H's as well, we need to put a 6 here. This results in us having 5 times 2, which is 10, plus 6 oxygen atoms, which is 16. And since we have O2, we want to make it 16, we add an 8 in front. And this is the balanced equation. I'm going to do the next few questions on the next page, so there's more space. Reaction 3 is an example of a cracking reaction. Question 4.1.6. Define a cracking reaction. A cracking reaction is a chemical process in which a long chain of hydrocarbons is broken down into shorter chains of hydrocarbons that are more useful. Question 4.1.7. Gives the structural formula of organic compound Q. As we can see, we start with hexane, and it forms ethene, as we have 2 carbon atoms and 4 hydrogen atoms. So, hexane originally has 6 carbon atoms and has 14 hydrogen atoms. So, if we say 6 carbon atoms minus 2, we get 4 carbon atoms, and we originally have 14 hydrogen atoms minus 4 equals 10. So, if we add 10, we get butene to be our structural formula. Question 4.2. Study the flow diagram below. Question 4.2.1. Write down the IUPAC name of compound R. So, we start with 2-bromobutane. We then go through the process of hydrolysis. And when we take an alkane, a haloalkane, and we go through the process of hydrolysis, it then forms an alcohol. And since we start with bromobutane, the alcohol formed will be butane 2-ol, as the bromine from the second carbon would be removed and replaced by the OH. Question 4.2.2. Compound R reacts in the presence of concentrated phosphoric acid to form an alkene. Write down the structural formula of the major product in this reaction. So compound R, as we know, is an alcohol, and it reacts with concentrated phosphoric acid to form an alkene. Since the alcohol we have is butane 2-ol, the alkene that will be formed would be but2-ene, as the OH group from the alcohol will be removed and replaced by a double bond. So our structural formula will look something like this. And that's all for this video. Thank you.